Okay, so what needs to go in here? Let's do with the minus part. What do I need here? So when I click the minus button, it's going to load this part of the code. Again, when you click the minus, it will load only here. It's not going to load the multiply or the add up here. Okay, it's gonna load its own subroutine because this this name here is handling the minus button. This one is handling the multiplication button. If you want the minus to do all of them, then you need to put that comma and put it here. So now it does both of them. Okay, so we'll deal with this later. But you can have it so that one button can process maybe multiple functions. But for now, just one button per subroutine. So the concept is pretty much the same, right? You could just copy everything here, right? I would just make it simple. Copy everything here and paste it here. Because you cannot just directly call first num because you think it's in here. No, remember these are local variables. They're only visible inside this block of code. This down here is a separate block of code. And you can use the same variable names in here. It's fine. Because this is not global. Global will be outside of the scope here. If you put outside, then they'll be global. You cannot be defined in here. But since they're all local variable, then you can reuse them here. So all you have to do is this is same. The symbol will be like minus here, and I wouldn't call it plus. I would probably call it minus, right? A little bit more meaningful name. If you do that, then you also want to change down here to reflect that. And then we're saying like the first minus the second. And that's that, right? That should be it. And we can do the same for the multiplication down here. So again, just copy and paste everything here. Changes to multiply, and change that symbol to the X, and then copy that down here, and just multiply this. So we did them all. You could have it so that all of these three here can be contained within just one. Instead of add, we just say calculate. And then we'll check the button type. If it's a plus, if it's coming from the plus, then we use the plus. If it's coming from the minus, then we use the minus here. If it's coming from the multiplication, then we use the multiplication here. So we use a diamond shape, right? For now, this should work. Let's see. So we have 5 times 2.5 plus minus multiplication. Okay? So as soon as you can see, like when I click this application is it's called an event-driven program, right? That Visual Basic is. That's why when you click it, it runs the code. Click the plus, it goes in here, loads the plus in here, looks in here, run that line, this line, runs all these, get the data from that first box, get the second box, calculate total, outputs it, and done. Comes back out and it waits. So right now it's just waiting. It's waiting for an event to occur. Okay, so the program doesn't end until you close the program. That's why it's called an event-driven program application. Whereas if you write a regular, like a console application, it will end, and it will exit out, it will close the application. Okay, so an event is waiting, even though I have it. So that's why the data here still always stay, and I can calculate because some numbers are already existing here. Okay. So any questions how this is done? What if I say you want this to be not just numbers, or you want this to be like in dollar values, a dollar sign, $49, $54.5, something like that. Okay, so the formatting is one more thing I just want to quickly show you how you can format your code. So when you read data from the form, every time, okay, any number you put, even though you put a number 5, you expect it to be a number 5. If you put a character in here, a string here, when you read the data from the form to a field in here, okay, it's always a text. That's why it's called dot text. So the number can be a 5, could be like 25.5, could be a letter A. Okay, they're all going to be converted to text. By default, it's always text. It works here. It's okay, if it's a text, then how come we can calculate, because a text of, so again, when I see like if you see a text, like for example, if you put 5, that's a text, right? It's a character 5, not the number 5. It's a character that represents the number 5. That is different from you know, a number that is without the quote. If we do that, that's a decimal number if it violates the data type rule, right? So just remember this. Every time you read data in from the text field, it's always text. Okay, here Visual Basic automatically converts it to a data type that we want to use. So I'm using a double number, so therefore Visual Basic is smart enough to know that you're expecting a double type. So it will convert this text. If I enter number 2.55, that's a text. But it looks at this number, oh, that is a data type with double. It knows that that's a double. It will convert this to a double number. Okay. It would do that implicitly. Okay. So we don't do, you don't have to convert. In Java, you have to do that conversion. And by the same token, when you output your data, even though I put only numbers, I could just say, you know, if I put like label result.text, go to total. If I do that, and if I comment this out, for example, right? If you do that, then this is a number of double type. When you send this back out to the form, it's going to be converted back to text. Okay, it's not going to be a number. It's not a number. If you see, you can see it as a number, but in the actual data type will be just text. Okay, so what I'm saying is that anything here you see here is always text. Okay, so you read the number back in there, it's always text. You output it back out, it's always text. So what that means, if I do this, and if you want to, so typically we want to say, we don't write it here, but I can see if we have it in the code somewhere. It does it automatically for us. So usually we'll say this total number here should be converted to text, to string. Okay, this is really what happens behind the scene. We don't see it, but this whole chunk of data here needs to be converted to string. So this is a string function that is a part of this program here. It will always convert to string. So even though this number is a decimal number or a double number, it will parse it, change it to a string, which is text, then assigns it to a text. And that's why you don't have that the issue here, right? It's always a text. Otherwise, if I put a text here, you get a problem, like as you see here, different data type. But here, we don't see it, but it happens behind the scene. So with this text here, toString allows us to format our output. So for example, if I run this, the plus only, and if I click on the plus, say 2.5 plus 2 is 4.5. Okay, if I put like 2.125, I get a lot of decimal places now. So it's not really consistent. And if you want to have a dollar sign in front of it, then you have to do like this, right? Dollar you can do that, right? Give you the dollar sign, which is not very efficient. Okay, so what you do is that the toString has a very special way to do that. And here you put inside the parentheses, you put the letter, I think the letter C. Okay, the letter C, either lowercase or uppercase, doesn't matter. This is meaning it's currency. Okay, I want this total here to be displayed as currency. Okay. So same thing, I'm going to copy this and put it down here. Turn this off. Put it here. And I want this to be not currency, but it would have a number. The N's for number. If you use uppercase, it's fine. N for number. C is for currency. And then down here also, you can have the P's for percent. Okay. So let me turn this off. Comment that out. So I have three separate ones. Okay, so if I save this and run it now, and if I put some number here, 2.5 and 2.123, okay, so I get $1. Automatically puts $1 here for me. It truncates the decimal places to only 2. It doesn't matter how many decimals I put here. Okay, so this is by default the default setting. And if I do the division, I get a decimal number of 2. Right? Before I have, like, it varies. And the multiplication is percentage. They put the percent in front of it. So it's 533.66%. So by default, these have a decimal places in 2 places. And it also displays the correct symbol here for whatever the type is going to be. So if you want a currency, you put the C in here. If you want a number, which is the default, is the dot, the N, and then it's a percent. Otherwise, you have to do like I did. You put the $ in front, and then you append the other one to it, right? And if you want to change the decimal places, bless you, like down here, I want to, like the N for number. If you, by default, it's 2 decimal places. If you want to display in 5 decimal places, you put number 5 here. Oh, one more thing. While you're running your application like I did here, and if you forgot to close it, you go back in your code and you try to fix it, your code, and it won't let you type it. Okay, that's because your application is running, and just make sure you close it first. You stop it first. Okay, before you can continue. So next to the N here is the number of decimal places. If you want 5 decimal places for that, this is just number. Number type. If you want, 3 decimal places for the percent, and if you want, default is 2 already. If you want only 1 decimal place for the currency, then you put that number there. If you don't put it, it's defaulted to 2 places. So now, if you run this application and you do again 2.123, 4 point whatever, okay, you have a single decimal place. Minus has 5 decimal places. Even if I have only 1 number or no number, right, it was still going to add the zeros to it. And then this is 3 decimal places. Okay, so that's how you format the output. The data comes in is always going to be that. Now you cannot put the $ here. Okay, if you put that, get $4, that's going to be an error because this is a character now. It's no longer a number. So if I click it, your system will crash. Actually, it's very smart now. The older version will crash. Okay, the older version will not allow to put any special character here. I'm surprised. This version here, it cleans that for us, but it's kind of cheating because, like that, right? So it doesn't work. So currency. So when you input data to your fields, just don't put the dollar sign or a percent or any of that. It's the output part. Okay, the output is the currency or the percentage or whatever that is. Any questions on what we just did so far? How you format the output? Yes.
Since a lot of the code for calculators anyways is pretty much identical throughout each of the subroutines,
Mm-hmm.
could you not put like first numbers like something that kind of stuff in the class level rather than repeating it 3 times?
Yes. Yes, you can. Right. So he was saying was that you could put all of these, actually all of them here, except this one here maybe. You put that in the class level out here. Okay. So that you don't have to do this every time. Right? Save you these. Okay. So because it's global, I can access it directly within any of my subroutines, and then I have just one single line of code up here. Okay, you can do that. That's fine. And the reason why you do this is because if you feel that this number are going to be used again and again and again throughout your program, right? If it's used only once in your code, then you don't want to put out here. Okay? Because when you run this application, and then when I put some numbers in here, okay, then this will still be active. The memory location here will be storing the number 12 and 3. It's running, it's live until I close the application, then this gets wiped out. Okay, versus if I do it here, then it runs in here, it creates a temporary variable in here, it does its calculation, exit out, it deletes these from memory. Okay, so it clears the memory. Okay, so it's something that used only once in your code, put in local. If you feel that you're going to use this again and again throughout your program, put that in the global scope. Okay, so really good question. Okay, anything else? Let's see, anything I want to talk about? Concatenator, we talked about that. The string type is pretty straightforward. Okay, let's see, string is operator. Numbers, string. Just remember that your string has to be encapsulated or enclosed inside a pair of double quotes. Okay, and string has some built-in functions or properties that you can use, so that you can find the length of the string size. You can also convert it to uppercase or lowercase, and so forth. So if you look at like page 60, page 74, 75, 76, it tells you that. Okay. So like in the string, okay, let's see. This. I'll just do here in this example here. Okay, so string is just basically you declare a string, just anything, a string 1 as string, and the same way you can assign it a variable name right away. I mean a value right away is always enclosed in a double quote. Okay, I think the single quote is only for comment. You can use that. So, hello world, right? So I could put that out here, for example, and that string instead, because this label result, you can put anything there. It doesn't be number. It's just how you put it. So the calculation part doesn't really matter here. I can, you know, just turn all these off. It's fine for now. Okay, they're all there. It's fine. The string is it's gonna be, you don't want to do any conversion there. Just put str1. So you get hello world. If I run this now, you get just hello world. Okay. If you want to change that to all uppercase, all lowercase, you can do it inside here using this built-in function. So I have the string object here, and if you want to convert to a lowercase, I think you can do here, 2, right? The string here, you can do like string 1 dot 2 dot, and then you see like 2 uppercase, 2 lower, 2 upper. You can trim here. You're trimming any white space on both edges, both ends. Okay, we'll do some of these array later, but you're going to change the uppercase, which is a 2 upper, and hit enter, and then that's going to change all this to uppercase. So if you run, and you'll see that it's all uppercase, and lower will be just opposite, all lowercase. Okay, if you put any special characters in front like this, right at the end, you save, you run, those white space will be retained, as you can see here, but it's actually over here. Just to show that I can do like this, much longer. So you run, you see that it's way over here. In case there's some white space in front, you don't see, but it's there. If you want to trim those, then you can use the trim. So you can say toString trim. If you trim, that means trim both ends, and then that will remove the white space, and then you end up with just the hello world. Okay, so you can find the length of that as well. The length of the string is, you can do like that alpha length, and it will count the characters for you. So in this case, length dot that, it gives you 36 characters, including the white space. Okay, so if you count every character here from here to here, you have a total of 36 characters, and you can use that to do a lot of things in terms of string. All right, let's take our last maybe like break, and we'll come back, and I'm gonna go over the assignment. Okay, so we'll see you back in about 10 minutes.